This is Mr. Hanna. We're talking about the lesson 013 that's representing data on pages P40 through P43. It's going to help you a lot if you read the section after the notes because it will help make sense of some of this stuff. Representing data, you've done a lot of this already. There's a whole lot of this. This one's going to be a little bit long. A frequency table is one way you can represent data. You make tally marks and then put numbers to record how many times something happened, or how many times you have, or how many of them of that item that you have. We use a frequency table to draw bar graphs. So if I have a bar graph, it's like a frequency table, but the bars are not connected. It connects or compares categories with the bars. So if I have a frequency table right here of music types, you've got your categories, you got your tally marks, and you have your frequencies. So then we make a bar graph. You have to have a numerical scale on the left side. You have your categories on bottom. You have to have a title. The bars should be the same size, and then you make each bar the height that matches up with its respective number. The next one we're going to talk about is called a histogram. A histogram is like a bar graph. The difference is it shows how often a range of numbers occur. Bar graphs were events or things. Histograms are always ranges of numbers. And because histograms are ranges of numbers, they have to be connected. Unless you have a range that doesn't have any of them in it. So if I had, like, instead of 5 for 11 to 20, if I had 0 there, and then I had 31 to 40, had the 5, we'd leave one column. We'd still have it on the histogram, but there wouldn't be a bar coming up. And so then you've got your quantity on your vertical scale. You've got your ranges on the horizontal scale. Horizontal means flat, vertical means up and down. You got your title. And then you draw your bars so that they match up with their respective numbers. You are probably most familiar with line graphs. A line graph shows how data changes over time. So if I had this little chart with years and the amount of sales, and I have that title, in 2009 we had 1,500, in 2010 we had 1,750, in 2011 we had 1,600, in 2012 we had 1,800. So we come over here. We draw a graph. The time, whether it's years, months, dates, whatever, that goes on the horizontal scale. The amount, that goes on the vertical scale. Now, since my first number was 1,500, I didn't want to go from 0 to 1,500. So you see this little squiggly line, that's a break in the graph. You use that for left out numbers. And you put a dot. 2009, 1,500. 2010, 1,750, which is going to be between 17 and 1,800. 2011, 1,600. 2012, 1,800. Technically, you would connect these dots with lines. I just wanted to make sure you could see the separate dots. Stem and leaf plots are a shorter way to write a large group of data. For the amount of data I have in this example, you probably wouldn't want to do it. You might, but you probably wouldn't. You do that when you got a huge list of data. Things you need to know for stem and leaf plots. The smallest digit forms your leaves. Bigger digits, and you can have 2-digit or 3-digit stems, form your stems. They can be 2 or more digits. Even if you don't have numbers for that particular stem, you can't skip it. And you always have to have a key at the bottom to tell people how to read it. So the first thing you do is you draw your stem and leaf. Sorry. You draw your stem and leaf graph. Then you start with your smallest stem, 8, because I had 83, then 90, then 100, or 10, because that's 10 tens, then 11 tens. Notice I didn't have any numbers that were in 111 to 119 range. Actually, 110 would fall under that stem, but I didn't have it, so it's left blank there. 120, I had 3 numbers. 130, I had 3 numbers. Notice how every number up here matches the number of leaves that I have. Okay? The way you read this, the 8 and the 3 in that first line make 83. The 9 and the 2 make 92. The 9 and the 7 make 97. The 101 I write as 10 and then a 1. I didn't have any 100 and teens. 112 or 121 is 12 and 1. 125 is 12 and 5. 129 is 12 and 9. You see the point. Now if I had, say I had another 101 up there, then I'd have to have another 1 right there. You have to have the same amount of leaves as you had original numbers. Okay? You've got to have the key down here to tell people how to read it. The leaves start with your lowest number. 0 is lower than 1. 2, 3, 4, 5. If you don't have them, you skip them on the leaves. You don't skip them on the stems. We got 2 more to talk about. You have circle graphs. The nice thing about circle graphs is you don't actually have to draw them for the EOI. You will have to know how to analyze them. And most of the time, you don't even have to do this calculation stuff. But you need to know how to do the calculation stuff. If they give you percents, it's pretty easy. You change the percent to a decimal. So if I have 75%, I change that to 0.75. Then I multiply it by 360 because there are 360 degrees in one circle. 0.75 times 360 gives me 270. So that would be an angle that looks like 3/4 of a circle. If you don't have numbers, or if you have numbers but not percents, the first thing you have to do is find a total. So I gave you an example. I had 8 cats, 10 dogs, and 2 birds. Add them up, I get 20 is my total. Then you make a fraction for each category. I chose to use the dogs, 10 over 20, and I multiply that by 360. Multiply by 360, I get 180 degrees. The last one we talk about is box and whisker plots. And this ties into what we did yesterday. Imagine that. Something we learned the day before, now we have to use again. Happens all the time in math. That's why you got to stay on top of your work. A box and whisker plot is a type of graph that shows how the data is distributed over a number line. So the first thing you got to do is you got to put them in order from least to greatest, and you have to find the median, and you have to find the lower and upper quartiles. Remember, once you find the median, you cover up the top half, and you look for the median of the bottom half, because a quartile is a quarter. To find the upper quartile, you cover the bottom half, and you look for the median of the upper half. Now this stuff, 4 through 6, that's stuff we didn't do yesterday. You have to be able to find the interquartile range. Just like when we were talking about range, it's the bigger number minus the smallest number. Since it's interquartile, I take my upper quartile and subtract my lower quartile. Now step 5 is to tell me if I have any outliers. Outliers are numbers that are a lot bigger or a lot smaller than the rest of your numbers. And there's a mathematical formula for it. It's 1.5 times whatever you got for the interquartile range. That was step 4. Once I know that number from step 5, I subtract it from my lower quartile. And if I have any numbers smaller than what I get when I subtract, that's going to be an outlier. I do graph it, but I don't connect it with the rest of the box and whisker plot. And to see if I have a bigger outlier, I add it to my upper quartile. And if I have any numbers bigger than that, that's an outlier. So I gave you a list of data, 2, 23, 25, 27, 29, 30, 35, 41, and 47. There's 9 numbers. So 29 is your median. I cover up the top half of numbers. I exclude 29, 30, 35, 41, 47. I'm looking at 4 numbers, 2, 23, 25, and 27. Well, the lower quartile is between 23 and 25. Add those together, you get 48 divided by 2, you get 24. Lower quartile. Then I get the upper quartile. I cover up the bottom half, including the median. I got 35 and 41. Well, that's not quite as easy to see that it's going to be 24 like the lower quartile was. So I go over here, 35 plus 41. I get 76, and I divide by 2 to get 38. Whoops, went too far. Okay, I got 38. Wait a minute. For my upper quartile. So then I do that last step. I take 1.5 times, I got to find my inner quartile range. 38 minus 24 is 14. Then I take 14 times 1.5, I get 21. My lower quartile is 24. 24 minus 21 is 3. So this 2 is an outlier. Oops. I go 38 plus 21 for my upper quartile to see if I have an outlier up there. 58 is the number. But my biggest number is 47, so I don't have an upper outlier. The last step is to graph. So you draw a number line. Make sure you include all your numbers. It's best to go a little bit past them on both sides. So I started with 0 and I went to 50 because I got 2 and 47. So all my numbers will be between 0 and 50. You can go by 5s, 10s, or more if you need to. So I put a dot for the outlier. I put a dot for my lower quartile, a dot for my median, a dot for my upper quartile. I also put a dot for my first value and my last value that are not outliers. See, 2 is an outlier. So other than 2, my first number was 23. So I have a dot on 23. I have a dot on 24 because that was my lower quartile. I have a dot on 29 because that was my median. I have a dot on 38 because that was my upper quartile. I also have a dot on 47 because that was my biggest number. You draw a box around the lower quartile, the upper quartile, and the median. And you put a line through the median. And then you draw whiskers out to your least value, your first value, and your upper value, the ones that are not outliers. Your homework is going to be page P43, and you have 7 of those, 1 through 7, all. And that is that.